Hey everyone, Ben here. Welcome back to another episode. Today with Allen Holub. Allen is a well-known author and thought leader in the world of agile methodologies and software design. We had a super fun chat about how agility shaped the industry, got corrupted, and now AI is doing it all over again. So without further ado, here is Allen Holub. Allen, welcome to the Start Work podcast. So glad you're here.
Glad to be here.
It's so cool having you because within the agile space, we had so many discussions on LinkedIn about all the practices and how the whole industry of agile, the agile consultancies, all the coaching certification is changing and has impacted the way companies and teams operate. So I'm really glad having you here to learn a bit from your experience and to sort of maybe get an idea of where we're heading to.
Okay.
But before we dig into that, maybe a quick introduction from you. Who's Allen Holub?
I have been doing this since dinosaurs roamed the earth. I started out, I started out doing hardware. I was building robots. And by the time I had written a couple of compilers and an operating system for the robots, I was a software engineer. I've written for lots of magazines, starting with Dr. Dobbs' Journal way back in the day. And introduced a lot of people to what was then C, actually, was the dominant language. Mm-hmm. I've been doing Agile stuff since before they even called it Agile. It's something that people don't get a lot, is all the Scrum people trot out this "we were first" nonsense, which is complete nonsense. But the Agile Manifesto, of course, was a 2002-ish, and people were doing it for 5, 6, 7 years. I don't think I ever worked for a company that was not Agile at some level. Mm-hmm. Though nowadays I'm unwilling to use the word. It's turned into such a putrescent pile of garbage, what they call Agile, that I'm not willing to actually identify with the word anymore. I was talking with Kent Beck a couple of months ago. We were both speaking at a conference, and he's not using XP anymore as a term either, because it's just been turned into garbage by people who don't understand what it's doing.
So why is this happening?
Why is it happening? Because big corporations decide that they have to be Agile, but they don't know what that means. So they take whatever garbage they're doing and they put Agile labels on it and say, yeah, we're Agile. Huh. And meanwhile, you've got the Scrum industrial complex making money selling certificates to people that don't know what they're buying. And so Scrum, I talk to Scrum people and I complain about it, and they say, but that's not actually Scrum. If you actually do Scrum, as it says, nobody's doing Scrum as it says in the Scrum guide. It just doesn't happen. It's a myth. So the thing that they call Scrum is just also a sort of a pile of smelly garbage. So there we are. Which is not to say that the principles and the techniques and the reason why Agile originally existed isn't true and correct anymore and useful.
What would that be for everyone who's not super familiar with that? Could you walk us through it a bit?
What makes it Agile?
Yeah.
Literally that it's Agile, that it's flexible. So you have to be able to accommodate change. Adaptive applies to what you do, and it applies to the way you do it. Mm-hmm. So you have to be adaptive. You have to, and by adaptive, I mean that we have to be learning as we're working and adapting to what we learn. So, and again, both learning about how we're working and learning about what we're building. So if you want to, at the core of all traditional so-called Agile ways of working, what I think of as effective ways of working is this notion of very small batches, building really small, building the most useful thing you possibly can, releasing that to people, getting feedback, and then adjusting what you're building based on the feedback. That's the core of it.
So it's not about processes.
Processes and all that garbage and Scrum backlogs and meetings and
practices.
Most of the Scrum practices are not very effective either. Some of them are. There's some practices that are extremely effective. And in fact, in our new AI age, are even more important than they were before. Test-driven development comes to mind immediately. It's a very, very useful and effective way to build software.
How?
Because you start with...
how in the context of AI?
How in the context of AI? Well, when you're talking about AI, there are a couple of issues associated with AI. One of them is that in spite of all the hype, you can't really... We're not living in Star Trek, right? You can't say, hey, computer, write me a program that does X. Yeah. It doesn't work that way, right? It produces this huge pile of amorphous glob of software, right? That might appear to work. It's not production quality. If it fails, you're in deep trouble because you don't understand how it works. And which is not to say that you can't use that in useful ways. Is using something like vibe coding to get a prototype out the door quickly or do a proof of concept or something. It's great for that. But for making production code, it just doesn't work. So you need to be able to contain the damage. And there are a lot of ways to do that. Architecture, for example, if you have a component architecture, you have a bunch of very small components that talk to each other across well-defined interfaces. Maybe microservices, maybe something bigger, but components at least. Then if you say to the AI, build me this component, right? The component has a specified interface, it has specified behavior, so on and so forth. You can then test that component as a black box pretty effectively. So testing becomes extremely important, and putting the code into small capsules rather than one big spaghetti mass is important also, because that controls it, that puts it under control. If something goes wrong, you know where the problem is. And if you need to fix it, the blast radius is contained to the component. So getting back to TDD, with TDD, you're writing the tests first. And a test in the TDD sense is really more of a specification than a test, is that it is a test. But for the purposes of building code using test-driven development, what you're really doing is providing examples of how you expect the code to be used, and then making sure that those examples work. And when you're doing TDD, of course, you probably are also building unit tests at the same time, which is why people get confused. So things like corner cases and that kind of stuff, yeah, we have to test for that stuff, but that's not so much part of the TDD process as is the basic functionality, the thing that you're building. And so that test is a specification, and that's a prompt. Because you can say to the AI, okay, I need you to build me something that works as follows, and you have a well-defined specification for that. And then you can build that up incrementally. TDD is an incremental process where you start off with a test that tests just a small piece of what the thing has to do, and you get that working, and then you add the next piece. You add the next piece, and you keep going until it's fully functional.
So you iterate towards the specification by adding another test and adding another test.
That's right, which is exactly,
you end up with the correct prompt.
Right. Well, maybe you'll end up with the correct prompt, or maybe you will develop the code within a context with a series of prompts. But either way, the two ways of working fit together really nicely. And it gives you a way to arrive at a solution that is at least contained, if not ideal. You still don't know how the code is working. Right. And there are wars happening right now about whether you should understand the code or not. Right.
But it's never been easier to understand the code.
It's never been easy to understand the code. And you look at LLM generated code, and it's like, it's using GitHub as training material, right? Well, GitHub is not exactly a font of perfectly designed, perfectly executed, well-written code, right? So the code that it's going to generate, since it's mimicking GitHub, is going to be of GitHub quality, which is not very good. So it's going to have to be fixed. And the argument is, should you bother? And that is an argument, the answer for which I think depends a lot on context. But if the answer is yes, then every time the LLM spits out a bunch of code, the next thing is some human beings got to look at it really closely and fix it. You've got to refactor it and make it better. And even that process, right? Generate the code, examine it, refactor it. That process, at least in my experience, is still faster than writing it from scratch by hand. So there's some advantage there, though it's not the huge advantage.
But you're basically doing pair programming all day if you do it this way.
It's not pair programming, because pair programming, you're having a dialogue with the other person in the pair. Pair is two brains working together, but LLMs cannot think. An LLM is not half of a pair. So it's not pair programming at all, but it is a little faster. And it's more fun because the LLM will do all of the drudge work that I at least would prefer not to do. I don't spend a lot of time looking junk up on Google or whatever, because the LLM can give me answers to those kinds of questions faster than I can look them up in other ways. But it's still that particular way of using LLM, which is not the only way, but that particular way is going to give you some speed advantages. And it's going to take a lot of the drudgery out of the programming, which makes it more fun, at least for me.
It's interesting that you mentioned speed because like I always advocated for the main feature of being agile is to really gain some speed in order to react fast on what's happening. But people would argue that speed is not the ultimate result or the goal of actually being agile.
I would argue that the speed in agile comes from not building things that nobody wants.
Mm-hmm.
So it's not so much that you're working faster. You're not.
So
what you're doing is not working on things you don't have to be working on. And that gets it out the door faster because you're not wasting time.
Yeah. So it's the speed in a different dimension when you work with AI.
Well, the code is coming together faster.
Yeah.
Right. All the time you would have spent in Google or whatever.
Yeah. You click like faster on the keyboard.
Right? It writes all this rote stuff that you would otherwise have to look up and copy paste. Mm-hmm. It just does all of that drudgery for you. It's not as fast as people claim, right? If you think about product development and programming in particular, we spend maybe 15% of our time coding, if that, right? The rest of our time as a programmer is spent with architecture and thinking about stuff and making product decisions and talking to customers and testing and all these other things that we have to do in order to code.
Yeah.
So even if an LLM did 100% of the coding, we'd still only have about a 15% gain in overall product development speed. So
go ahead.
You were going to say something.
I was about to ask, like, I'm not a software developer. I don't have a background in software. I come from a background of hardware engineering, mostly electronics. I learned a bit of Python, but by all means, I wouldn't consider myself a software developer. Mm-hmm. So this might be an odd question, but we already talked about software architecture. You mentioned microservices, and you kind of advocated for it in what you said, or at least that's how I.
Well, not necessarily for microservices. Is you need a component architecture, and which the AI people are calling agents.
Okay.
And the idea of a component is that it is it has a single responsibility. It does one thing. It's small. It has impermeable boundaries, right? In other words, nobody knows what's going on inside there. And it has a well-defined interface that it uses to talk to the outside world. And a system that's made up of a collection of intercooperating components is probably the best AI system architecture as well, because each component stands alone. Each component if something goes wrong inside the component, it doesn't escape, that problem doesn't escape from the component. I was talking about two ways of approaching LLM ways of working, AI ways of working. One of them is the inspect and refactor approach, but the other one is just leave the code alone, right? But if the inside of the component is this amorphous goo of code, in a way you kind of don't care, provided that you can really, really, really thoroughly test the component from the outside through its interface. So that gives you a way of working where you don't have to do close examination of the code because the blast radius is contained inside the component itself.
Because I was asking about this because I was seeing some people making an argument for having throwaway monoliths instead. Like if it's so cheap to just generate like a huge amount of code.
Well, that's wishful thinking. All I can talk to is my own experience. I haven't done a bunch of practical studies here. But what I find is an LLM can kind of fix problems. But if the LLM created the problem, the odds of it being able to write better code to fix it are small. Right? It produces different code, and there's always this like the last 10% problem, right? Which it just can't handle at all. Sometimes you talk the prompt into a corner and it can't escape from it. It's just, you can't do anymore, right? You have got to do the rest by hand. But the thing is that trying to give me the question again, just so I can rethink my thoughts here. We're thinking about.
I was interested whether you would work in small components or you would much rather just have a big glob, and when it's not working anymore, the problem with the big glob
is that when something goes wrong, and it will, it's very difficult to fix.
Well, you just scrap the whole thing and create a big glob again.
Which will also have something wrong with it, which is impossible to fix. Right? You can't escape from that right now. Right? So the people who are thinking in those terms are thinking wishfully. They're thinking, well, we'll be able to get the LLM to fix the problem for us. And it can't do that now, but By the time I need that, it will be able to do it because the technology is moving that fast. And that's someplace where I would argue with those people. I think the technology is not on a logarithmic curve. I think it's more linear, and I think it's flattening out now.
Okay.
There are some limits to what an LLM can do vis-a-vis training, right? We've just about reached the limit of new training because there's starting to be enough LLM generated content mixed into the training material that we're getting into these doom loops where the LLM is training on its own output. We have to, that's a very hard problem to solve. And we can try and solve it by mixing in reliable data, but there's much less of that than there is than the internet.
It's slowly generated. It's hard to generate like organic data, like genuine, organic, good quality data.
Well, yeah, but if we just focus on code, right, just on the LLM itself, just on coding with the LLM itself, that's a little bit easier because we're writing code all the time.
Yeah.
Now, LLM generated code, of course, is worthless for training an LLM to write code. So
on the other side, this gets mass produced at the moment.
Well, the LLM
widely available.
Is more widely available, though people aren't publishing it, so you don't find it too much. I guess you find it on GitHub now because people are putting their LLM projects on.
They're flexing with their GitHub contributions.
Yeah, but the point is though that we can provide training material in the sense of handwritten code, which the LLMs do not have right now because they have not been on GitHub, for example. So a company that was running its own local LLM, which is not that hard, right? You can just install a model with Docker image or something, can use its own proprietary code bases to train the LLM to help it produce more code for its own use. And there's nothing wrong with that. And the quality is going to go up because the model is being trained on higher quality code. So it's going to produce higher quality outputs. But it's limited in the choices that it can make to what it's trained on. So it's not going to be doing anything innovative.
And it's not going to be better than what you've done.
No, it's never going to be better. LLM is never going to produce code that's better than what's in its training.
Yeah.
But, and it's not really innovative. It's just picking stuff. It's picking stuff based on statistical analysis. It's picking stuff based on context. If given a choice between two different paths, it will pick randomly, right? But there's no thinking involved anywhere in this process, right? It's not thinking things through. It can't be innovative because that involves a kind of thought process that an LLM can't have. Maybe as we move towards AGI in 10 years, we'll be there, but we're sure not there now. So there's a limit to what it can do. And a lot of the product people who are pushing for just vibe coding kind of don't care how good it is as long as it works well enough that they can produce something that they can sell. And I can't argue with that, right? As we're in the business of making money. Those are going to be sort of fly-by-night products because they will break. And once they break, nobody will know how to fix them. And the only choice then would be to redo them from scratch, which again will bring up different problems than you had before, but it's not going to get rid of any problems by doing that. But I guess kind of what I'm getting around to in several different places is that there's a human in the loop. There has to be, because that's where the innovation comes from. And that's where the structure comes from. And that's where fixing the things that the LLM can't see to fix, right? LLM doesn't understand the code it produces. It doesn't understand anything. It's all patterns. Right. So it takes a human being to understand it in order to actually get it fixed. So the sorts of skills that people need in order to be viable and continue to be viable in an LLM market is not coding, but it's all this other stuff, testing and understanding and architecture and all of the things that you need to do to be a really good programmer, but are not coding. Right. The ability just to write a simple piece of rote code in Python is not very interesting anymore.
But isn't that actually like a really good development? Because you would argue that there are no coders anymore. Like you would be a full-fledged product developer. You would need to be a full-fledged product developer.
I think if you are simply a coder right now, that you should look at look at getting into another profession, is that over time there is going to be less and less demand for somebody who is just a coder. All they do is they get a fully blown spec in front of them and they code it up and then they move on to the next spec. If that's all that you're doing right now, I think your job is in jeopardy. But again, programming is not that. That's a very small part of programming. And most people in the business who I interact with, and again, it's not a real study, right? It's just people walk up to me at conferences.
Well, you have
but they're not coders. They are programmers, right? So they don't have to worry, but they will have to be thinking about things like, how do I adjust my resume to reflect all the things that I do that are not coding, but are nonetheless essential for getting a piece of software out the door, right? And testing is a big one. So if you have a big blob of code inside a component, you've got to test that. You've got to test that to an extreme that a lot of people don't test nowadays, because the human written code doesn't have to be tested that thoroughly. It's not going to do completely random weird stuff.
Or they just don't test at all and just instruct the LLM to write tests and leave it that way.
The tests that I've had come out of Claude, at least, have not been earth-shatteringly good.
But some people claim on the internet.
I think if you gave Claude a set of GWT specified tests, that it would produce the code to run those tests quite well. But it's not going to come up with the GWT suite, right? It's not going to come up with the test suite.
It's so interesting that everybody makes their own experience and claim their own story. I interviewed Henrik Nieberg, and his argument was like, "Oh, I want to get where I don't have to write and read any of the code or test any of the code,
which
and have
would be
the
great,
LLM."
right? It's a goal that I don't see any problem with that. We're just not there yet. Now he's working on the agents that his company is working on are bigger things than what I'm talking about, right? He's talking about, plan this trip for me, right? That kind of stuff. And that is its own set of problems that requires a lot of hand tuning and stuff. The LLM is helpful for that, but excuse me, but it's not the be all end all of solutions. And they're using LLMs, of course, to generate a lot of that code. But if it's a product, it has to be reliable.
Yeah.
And if it's going to be reliable, it has to be really, really, really deeply tested, which means the code has to be written in such a way that it is testable. And an LLM will not do that unless you direct it to do that. Right? So if you're working with a component architecture, I keep coming back to this. It's not the only architecture, I should say. It's just what it seems to be on my brain today, at least. But if you're talking about a component architecture, you can black box test each component. And you can test the interaction between components. And then you can infer that if all of that is okay, that whatever's going on inside the component is fine. It might be bigger than it needs to be. It might be sloppier than it needs to be, but kind of who cares? And that's kind of what Henrik is talking about, right? Because you could build the insides of those components using an AI without really looking at the output. It's just using it, provided that it passes all the tests. But asking the LLM to come up with a full test suite that will test those components to the extent that they need to be tested, no, they can't do that right now. And if you start putting microservices into the scene, right? If you take the components and distribute them across a network and run them asynchronously with respect to each other, nobody can test that. Spotify can't test that, right? Netflix can't test that. They're testing in production because they have no choice. And an LLM is not going to be helpful there, right? Is that, again, requires monitoring and that sort of stuff that
I want to get back to the realm of Agile.
Okay.
Because what happens with our episode here is something that I see happening out there with a lot of people from the Agile world. It seems that people stop talking about Agile or the Agile coaching, consulting, whatever industry, and move towards AI. So everyone who was an Agile expert on coaching and training suddenly became an AI expert. And I'm wondering what has happened to...
What's happened is that the AI has sucked all the air out of the room with respect to the consulting industry. Companies that I used to work for, when I would come in and help them doing processes, they don't want to hire me to do that anymore. They want to hire me to come in and talk about AI. And So I do that because I have to make a living. And which isn't to say that all of that other stuff, all of that stuff that has, how do you make software in an effective way, that's all just as necessary as it was before. But again, it's different because the LLM kind of means that the processes that you used to use are going to have to be tweaked in order to accommodate these new tools. But we're agile, right? We've always done that. Mm. Right. And we've been working in agile ways for 30 years now. And over the course of those 30 years, new tools come onto the scene that change the way that you work. And then you adapt to that, right? That's what being agile means.
But aren't the answers on different flight levels? Yeah. When we talk about agile, we always talk about like a team or a set of teams and how they collaborate, how they work together. And when we talk about like, let's say Claude Code, we would talk about how does one single developer contribute to a certain product or service.
A developer cannot produce a product. I don't care what tools they're using. But it's not Star Trek. Scotty can't pick up a microphone and say, write this product for me.
It's not Star Trek, but it's different in a way that Agile is, or at least that's what I saw, is that Agile is aiming at how to orchestrate, and LLM is just augmenting a developer.
What do you mean orchestrate?
Like if you look at the Agile frameworks, like if you look at Scrum is basically describing a team or a Scrum team. If you look at SAFe, it's describing certain teams, how they work together.
Yeah, but none of that garbage is Agile though. None of that garbage has ever been Agile. Okay. SAFe in particular. SAFe is opposite of Agile. SAFe is literally Agile in name only. The word Agile appears in the name and it doesn't appear anywhere else in the process. There's no agility in SAFe at all. So let's throw it out. Scrum was originally pushed as a wrapper around extreme programming that made extreme programming more palatable to management. Okay. And if you look at the very, very first book on Scrum, the Beadle and Schwaber book, it says it right there on the back cover. Exactly what I just said. So Scrum was never about Agile either. It was about trying to make Agile look like something else so that managers that were hostile to Agile would put up with it nonetheless. And none of the things in Scrum are required for agility. None of them. Or to put it another way, Scrum, XP can produce software without Scrum, but Scrum cannot produce software without XP. The whole notion of a user story, that's XP, that's not Scrum. Nowhere in the Scrum guide does it talk about user stories, right? Is that none of the practices that Scrum teams talk about that matter are in the Scrum guide. The Scrum guide is all about meetings. And if I can produce software with 0 meetings, I'm happier. I don't want any of those meetings. So Scrum is not Agile either. Scrum is just I don't know what it is. It's a layer of process that might provide some structure in an organization that had none. And I'm not saying that's not useful. But if the organization is mature and it's full of people that know what they're doing, they don't need Scrum. Scrum is going to do nothing but slow them down.
But who's providing the new structure in the age of AI?
Why do you need a structure of that sort? Why do you need some kind of control-based structure?
People are looking for it. There's a market for it. Like consultants sell it. People buy it.
I think building a process just because there's a market for it seems like the worst kind of.
It seems like the basic foundation of many consultancy companies out there.
Yeah, but I guess most consultancy companies are
full of shit.
Yeah. Yeah, I'd say that. The people who have always been the best consultants on the Agile space have been the individuals, not the big consultancies. Yeah. The big consultancies have never helped anybody do anything useful. Because for the most part, those companies get hired by upper management to tell upper management what they already want to hear. Upper management makes a decision and they hire a consultancy to come in and say, yeah, you made the right decision. And that's not helpful to anybody. Yeah. Great way to spend a bunch of money. I wish I could get paid as much as Deloitte gets paid. But
Me too.
Right. But the CEO types that hire companies like that will not actually hire the people that know what they're doing. Because the people who know what they're doing are usually individuals or very small consulting companies. And they're not even considered.
So you think the set of processes emerges from the organization, from the individuals who work on the product.
Yeah, and that's core to agile thinking. That's right back there in the Toyota production system in 1970s. Is that the people that are doing the work are by far in the best position to figure out how to do the work. And that was built into the way Toyota did stuff in 1970, is that every workstation team was in charge of figuring out how it did its own work, which they would then document because this was a factory after all. We don't have to do some of the things that Toyota did because we're not a factory. But the point is that the teams figured out how they were going to do their own work. When something went wrong, somebody pulled the andon cord, right? You can hear about the andon cord, and some part of the assembly line stopped at that point, and it did not start up again until the team and the teams around them could figure out a way to change their processes so that the defect could not occur again. And then they would start up again. So they were changing their processes all the time based on observed behavior of the software development system. And that is just as valuable today as it was in 1970 when Toyota came up with this.
But still, big companies struggle with emerging processes out of, let's say, a 500 people organization.
That's because they can't give up on control. There's a lot of big companies have never really grown past 1940s vintage thinking about how organizations should work. They think they make two big mistakes. One of them is that they think about military ways of doing things when the military itself isn't doing things that way anymore.
Like what?
Well, a squad in the military when it's working, right, in a battle situation, they're not like sitting around twiddling their thumbs waiting for somebody to tell them what to do. They're doing.
Right? You mean they're not waiting on the retrospective?
They're autonomous. They're given a strategic objective, and it's up to them to figure out how to get there. Mm-hmm. Right. And people in software, all too often, it doesn't work like that. You're told every little step of the way, right? And everything has to be monitored. You've got to do something exactly the way Scrum says to do it or whatever, right? And that doesn't occur in the military, at least not in the heat of actually working, right? Yeah. Is that you have an objective and people are smart and figure out how to do it, right? And because you have to have agility in that environment. Right. So that's problem one. And problem two is there is this mistaken belief that building software is factory construction, is manufacturing. And software has nothing to do with manufacturing. Software is a creative knowledge work thing. Right. It has more to do with, I don't know what good examples would be, but it's not construction. It's not building buildings. I talk about estimates and people say, well, you can't work without estimates. I couldn't build a house without estimates. And I'm going, we are not building houses. Mm-hmm. Right. It's a completely different situation. We don't have a set of well-defined set of materials at known costs. We aren't performing a set of operations like building walls that we've exercised 100 times before and we know exactly how to do it. That's just not what software construction is like. So as long as you try and take manufacturing principles and apply it to software, you're going to fail. Or at least you're going to work much more slowly than you need to. And that's a lot of the big corporations, they're stuck there. They can't escape from that manufacturing thinking. And they're so stuck there that they can't even imagine there are other ways of doing things. Right? As Lorman's law comes to mind immediately. Right?
Okay, so no manufacturing thinking, no military ideas that not even the military.
Well, not real military,
right?
It's a kind of funny notion of what that's like.
And not copying frameworks. What else should managers?
I don't think we need managers at
all.
Not well. We need somebody who can coordinate the teams because they're busy doing work, and it's nice to have somebody outside helping with the coordination.
Okay.
We need somebody that has strategic objectives and company culture and things like that in mind and can work with the key teams to make sure everybody's on track. Mm-hmm. We need somebody who can sit down with a team and go, what you're doing is okay, but if we did it in this other way, it'll work better with those 4 teams over there. So yeah, we need managers doing that. We need managers who are helping the teams. And the teams need resources. By resources, I don't mean people. I mean software or tools or whatever. Mm-hmm. You need somebody who can work within the bureaucracy of the organization and get that stuff. It's a support role, if you will. Certainly from a big corporation point of view, we need somebody on the scene who's going to look after you as a person in the context of the corporation. It's going to help with your career. It's going to give you advice. It's going to sort of generally smooth things out with the way that you integrate into the corporation. All these are valuable things to be doing. Telling somebody what to do? No, we don't need that. And people on top ordering people what to build, we don't need that either because it's too in Agile is we're probably going to build the wrong thing.
Mm-hmm.
If you want to build the right thing, you have to have this tight loop where you're talking to customers and saying, here's this thing I just built. How is it? And your customers have to say, well, that's great, in which case you're finished. Or they say, well, it's okay, but. As soon as you hear that word but, you go, there's work to do.
Sure.
Right? But for that loop to go all the way up to upper management and come all the way back down as a series of directives and a pre-populated backlog, it takes too long.
Yeah.
And that time to market is money. And so these businesses are actually working against their own best interests by working in that way because they're slowing the processes down. Generally speaking, and this is me speaking from years of coming in as a consultant and helping companies get better, the way that you go faster is by eliminating friction.
Mm-hmm.
And all of these things that people are doing in order to add control, add friction. As soon as you add control, you add friction. So the only way that you can eliminate the friction is to trust the people that are doing the work and to let them do it and to give them all the tools that they need and all of the support they need and then let them do their work. And if they weren't competent, then there's something wrong with your hiring process. Why did you hire them?
Maybe let's give our listeners out there a bit of a tip. Like if I were about to beam you into a larger corporation that is operating very, as we described, as they shouldn't.
Yeah.
What would be your first couple of steps? What would you do?
Well, I'll preface this by saying that really big corporations won't hire me.
Okay.
And haven't. It's the only work that
So they're doomed.
They're doomed. And I have occasionally worked
entirely.
Well, pretty much, yeah. I've occasionally worked one-on-one with somebody in an organization like that, like a CTO or somebody relative to the organization. But it was just give me personally some advice and help me do this thing, right? But in terms of quote transforming an organization of that size, I don't think that's possible. Right? Really, really big corporations, their culture, which is what's causing the problem, would be the same even if you fired everybody and then rehired from scratch. The culture would not change. Cultures are very, very
so the only thing that they could do is like provide funding to a startup.
They're doomed. It's the solution there is something like a skunkworks project, where the company spawns off a separate company entirely that is
new
left
people
alone and given a strategic goal.
Completely new people.
Well, it doesn't necessarily have to be new people, but it's got to be people who are not sycophants, right? Who aren't, are more interested in the work than they are in the corporation. But they have to really be left alone, though.
So no strings to the mother company, like
nothing. You treat them like
not
a startup.
Surfing on their
you should treat
shared
them,
services.
You should treat it like a startup that is being funded by the company. And if you look how actual startups work, the VCs are not in there micromanaging anything. And they don't know whether they're going to get any return or not until a year or 2 years after they make the investment. Is that they make the investment based on the trust that they have for the people that they're investing in. VCs do not invest in companies, they invest in people. So you put a bunch of people together and you invest in them and you give them a strategic objective and you let them run. Java was created that way. And Java went to hell when Sun Microsystems pulled JavaSoft back into Sun. Right? As long as it was working independently as a separate company, everything was great. But JavaSoft pulled them back in and you started having these abominations of stuff happening, all sorts of garbage happened. Java went downhill at that point. And it was because the skunkworks system worked.
Can you elaborate a bit on what skunkwork means?
Skunkworks, the original skunkworks was created at Lockheed Martin back in World War II because they needed more innovation in aircraft design than they were getting out of the bigger corporations. So they made the skunkworks and they were tasked with just doing the most creative, innovative, crazy stuff that they could to see what they would come up with. And they came up with all sorts of really interesting things that the larger factory could never have developed. And so they were, in a way, creative. I'm thinking think tank, but that's not the right word. It's an engine of creation that was not limited and constrained by the culture of the larger organization. They were completely on their own. And since then, I've seen that with several organizations where they'll spin off some smaller company in order to do something useful. And often the thing that smaller company does turns out to be better than the thing that the bigger company was doing. Because bigger companies, once they get big enough, they're not innovative anymore. They're just
they suffer from inertia
they're keeping the existing thing going, right? Their goals are different. The goal of a startup is to do something new and exciting and different. And the goal of a large established corporation is to milk money out of what you've got. It's to maintain what you have and preserve the money stream.
But I guess that's part of the life cycle. Like there's these quadrants with rising stars, cash cows, poor dogs, and whatever.
So if you win innovation, you have to then make startups.
Yeah.
And if a company wants to leverage the financial advantage of that, then they're the sole funder of that startup, and then they'll get all the return. But they can't interfere, because if they start interfering, if a company interferes with the way the startup is working, why are you bothering?
Yeah.
They might as well just be a team inside the company.
True. Good point.
Right. So that's the best way out, as far as I know. Now, sometimes you get some advantages there, and I see that even on a small scale. Often I haven't actually been called to do this in a while, though I'm happy to do it. But for a while, I was doing a lot of mob programming instruction. And I would, if at all possible, set up a place where people could mob in the most public way possible.
Why is that?
The reason for that is that they'd be sitting there mobbing away, getting work done, and somebody would be walking down the hall and they'd say, "What are you guys doing?" And they'd say, "We're mobbing." And they'd say, "What's that?" They'd say, "Come over, sit down with us, see what it's like." And then a week or two later, I'd go over to where that other group sat and they'd be mobbing too. And I wouldn't have had anything to do with that.
Yeah.
It's just that they observed it in practice and they were invited in and they could see how it worked. And that was enough to get them to try it. And that can happen in a skunkworks situation too, if the company is willing to leverage it rather than be threatened by it. A lot of companies, even when they make a skunkworks, are threatened by what's going on in there. But what you really need to do is by saying, you know, those folks over there are doing something really interesting. Why don't you go over and see what they're doing? If it works, bring some ideas back and use them. And that way you can gradually evolve a company in a different direction. The idea of a transformation, though, right? We bring in an army of consultants and we're going to have an agile transformation. That's just nonsense. I've never seen that work.
Allen, I really enjoyed talking to you.
Oh, good.
And thank you so much for coming on the show. If you want to reach out, if you have questions, what's a good way to reach you?
The best way to get me is on my website, which is holub.com, HOLUB.
Okay, I put it into the show notes. You can put it up.
Or you can even send me an email. I'm in business, so I don't mind people having my email address, which is just my name. It's allen@holub.com. And as you say, I'm on LinkedIn a lot, and I'm happy to answer questions and stuff that anybody sends me by DM on LinkedIn. I used to have Twitter on that, but I won't have anything to do with X anymore. It's just gotten too morally appalling to me. But I am on Blue Sky, though not with the number of followers that I had. There I'm at Allen Holub at bluesky.social. But any of those ways will work. And if you want to work together, we can set up a Zoom call or something and we can chat about what you need.
Awesome.
Move from there.
Thank you so much.
You're welcome. My pleasure.
And see you very soon.
Yeah.
Bye.
Bye-bye.
Thanks everyone for making it to the end of this episode. I hope you enjoyed the conversation with Allen as much as I did. If you're digging the podcast, do me a huge favor. Hit that subscribe button, drop a like, and if you're feeling extra generous, leave a review. It really helps us get these conversations in front of more people. We got some amazing guests lined up, so you definitely don't want to miss what's coming next. Till then, see you soon. Bye.